So last chapter we learned how to take and multiply something like negative 5x times 2x squared, right? I mean, there's something on the test just like that. You have to take the 5 and the 2 and multiply them together to get negative 10. And then what do you do with the powers on the x's? You add them. And there is an unwritten 1 on this first x. So you get x to the third. And so when we say distribute, you are doing what we did last chapter, however many times is necessary for each term in parentheses. So the first distribution here would give me negative 10x to the third. And then the second distribution would be negative 5x times 3x. I multiply the negative 5 and the 3 to get negative 15, and then I have x to the second.
Good job.
And then I would distribute negative 5 times negative 8 is positive 40, and then attach the x. So I'm just multiplying that negative 5x by each and every term that you see in parentheses. And that's the distributive property. So it does connect to what we did last chapter. When you multiply two letters that have the same base, we add the powers, and we multiply the numbers out in front. So negative 10x cubed minus 15x squared plus 40x. You don't need to show this work up here. This is what we learned last semester. You're doing that, hopefully, at this point in your head, doing the multiplication in your head, adding the powers in your head, right?
I could do that.
Good.
Me too.
So this next one, the question is, does it work to distribute when you have the number on the other side of the parentheses? The answer is yes. 5 times 9 is 45. 5 times negative 2b is negative 10b. So there is left and right-hand distribution, and it works both directions.
Whoa.
So that's distributing. Now, distribution, just like multiplication, has an opposite operation. The opposite operation of distributing is factoring. You could even write on here, you might want to write somewhere on here, factor means to divide. But it's a special kind of division in which we are pulling out the GCF. GCF stands for greatest common factor of each term. So it's multiple divisions, just like distribution was multiple multiplications. So that's what we call factoring and not just division. But it really is just division. I'll show you what I mean. I'm hoping, coming into this class, I think it seemed like most of you guys have the idea of what a greatest common factor is. You probably learned how to find the greatest common factor by using factor trees and then matching them up. You remember doing that? Okay.
Yeah.
So you have that background. What we want to be able to do is to look at two terms, like in this factoring example, 2y and 12, and look at that and see that the greatest common factor, the biggest term that will divide into each of these terms with no remainder, is 2. And then we've got to kind of extend that idea to variables a little bit. So I would write down as a GCF 2, and then I do my division. I'm dividing the first term by 2 and the second term by 2, and I'm writing what's left after that division in parentheses here. So I factor out the 2. 2y divided by 2, what does that equal?
Y.
Just
Y.
yeah. And then 12 divided by 2 is 6. And so this is really doing what we did last chapter. We don't see it here because we don't have a variable top and bottom, but when you have a variable in the top and a variable in the bottom and you're dividing, what do you do with the powers? No, that was when you're multiplying. Subtract. So that's how it relates to what we just learned. That's why chapter 7 is before chapter 8 here. So what's the greatest common factor here in the second one? 3 definitely, and then the x as well. Now you said x because you noticed there is an x to the first power here and an x to the second power here, right? So if I've chosen the correct GCF, when I divide each of those terms by 3x, they should divide in, we say it divide in evenly. What we mean is there shouldn't be any remainder, or in algebraic terms, there shouldn't be anything left on the bottom. Yeah. Everything should cancel. So like the 3's canceled equal 1. X squared divided by x to the first is just x to the first. Just subtract the power. And then you copy down the minus sign. 18x divided by 3x is just 6. It's just 6. So 18 divided by 3.
Oh, you're right, Miss John. You're right. Oh yeah. I'm a little rusty.
Okay. So pull out the GCF and then divide. Okay, each and every term by that GCF. So that's. I hope that makes sense. If you need more help on finding the GCF, I can do that as needed by showing you a factor tree. We're going to do several more. So I just wanted to show you that distribution and factoring are reverse operations of each other. Look at this right here. If I take the GCF and I multiply it by y, I get 2y.
Yeah.
And if I take the 2 and multiply it or distribute it to the 6, I get 12. So if I multiply out what I got when I factored, I get back to the original. So that's.
Is that how you check it?
That's how you check it.
Check it.
The problem is that will only check that you've factored out a common factor. It won't necessarily tell you found the greatest common factor. The greatest common factor, you have to just know how to identify that. Because even if I only factored out a 3 here and not a 3x, when I distribute, I'd still end up with the original problem. So, but distribution will help to check, at least help to check your factoring. All right, so a little more practice here. Let's do this with 3 terms here. I have a negative x cubed and a 9x to the 4th.
Yeah.
So negative 1 times 9 is negative 9. The x to the 3rd and x to the 4th would equal x to the 7th. And then being careful of my signs, the negative times the negative here will give me a positive 2. And then x to the 3rd and x to the 3rd is x to the 6th. And then finally the last term here and here.
Wait, no. Is it 6? What is it? Ooh, you're right, Rena.
It's 6 because the rule says, here's what we're doing. We're multiplying these two together. When we multiply same bases, what do we do with the power?
Yeah. Oh, add them.
So for that reason, it is x to the 6th. Then the last term
Good try. Good try.
on here is minus 7x to the 3rd.
Wait, how do you get negative x to 7? So, okay, no. Wait, how do you get? Because negative x is cubed, so you add the pi together. Okay, yeah.
Yeah.
The negative.
Okay, well, let's go ahead and try this. Try this one right here. Just try it right now. Go ahead and do the distribution. Write down the 3 terms that you should get.
Can I get my pencil?
If you need it. We shouldn't need our calculators as we go through this.
Oh, it's just for dollar check.
So the negative times the negative stuff.
I really love it.
Can you get back before we finish now? You try.
Give me your sword.
Let's go quickly. So we're going to go on to the next page here. Try these on. Everybody try both of these.
This is a tough unit,
Try the second one too. You already got the first one. Try the second one.
Like your glasses. Where'd you get? Yeah, where'd you get? Well, I got my glasses at Big 5, but they didn't anywhere.
So this is negative 6x plus 10y minus 8. And this one over here, so everybody had a chance to try it?
Well, this one
I did it right.
15n to the, it ends up being 4. Yeah, invisible 1 on that first one. And then minus 5n to the 3rd plus 40n. So there it is. That's the distributive property with a slightly bigger polynomial. So monomial times a polynomial. And really you can apply this principle to multiplying any size polynomial by any size polynomial. Unfortunately, they stay fairly small.
Wait, what does polynomial mean?
Polynomial means many terms.
What's the monomial?
One term. Monomial.
Oh.
Right. Going the other direction, the greatest common factor, kind of like what we did in that first one, if I'm going to write down the GCF on this line right here, what is the GCF of these 3 terms? 5 is part of it. 5 is part of it. There's an x that shows up in each one. Now, we're going to go ahead and do the division here.
Yeah.
And the division looks like this. Take the 5x to the third, divide it by 5x.
You put the GCF under the 5x.
Under each of the terms, yes. So, what's 5x cubed divided by 5x?
3x.
No.
Oh, look in your notes.
The 5 divided by 5 equals 1.
Yeah.
X to the third over x to the first. What do you do with the 3 and the 1?
Just one, right?
No, you subtract.
Let's be 2.
Yeah, so it's x to the second.
Let's go.
And then in this one, 25x squared divided by 5x is
5x.
5x, good. And then 45x divided by 5x is just not, yeah. And once again, you can check by distributing. What's up?
No, you.
Not yet. So 5x times x squared is 5x cubed. 5x times 5x is 25x squared. 5x times 9 is 45x. No, don't go in. Don't go in there. You need to wait. All right. This next one, can you tell me what the GCF of this next one is? 13, yes. So we're on problem 2 here. And it's 13x to the third. So then I need to divide, so we're on problem 2. Yeah. Divide 13x to the third into each of these. So when I divide 13x to the fifth by 13x to the third, I get
7x.
Good one. Good job. Nice try.
You told me it was 7.
What do you got? Keep trying.
X to the second.
x to the second is right. Plus
2x.
Plus 2.
just 2, yeah. Good. So I'd like you just to try this one right here and this one right here, and that's it. So try each of those on the now you try, please.
He's really smart, you know that. So.
Those are the 2 answers for the now you try. We're only going to do those 2. We're not going to do all 4 of them. 2 of them.
I just did all 4 of them.
Oh, good. So make sure you have those now. I'll give you another 30 seconds to get that last one written down. And once again, we can check it with our multiplication. If I had checked it over here, I wouldn't have missed the x to the third, because x and x to the third is x to the fourth. So distribute to check.
He's so smart, Mr.
Sometimes. All right, this is a Common Core sort of problem where we're going to model mathematically what's going on here. It says that the helicopter, you have to look up here because yours isn't black and white. So a helicopter landing pad or helipad is sometimes marked with a circle right here inside a square so that it is visible from the air. What is the area of the shaded region of the helipad at the right? So this is a generic dimensions here. We've got area, this is a little bit of geometry, area of the square minus the area of the circle will give you the area of the shaded part. It's a box. That's a square. So I'm doing a little pictograph here to show you what we're doing. Okay, we're going to get the area of the square. The area of the square is 2x squared, and the area of the circle, we have to use the area formula for a circle. It's pi r squared.
Mr.
And instead of r, I have x. So it's pi x squared. And last chapter, we learned what to do with a number and a letter raised to a power. We've got to apply this power to both the number and the letter. So this would be 4x squared minus pi x squared. And they asked us to leave our final answer in factored form.
Is that factored form?
No, it's not. Factored form would mean taking out the GCF from those 2 terms, if there's one besides 1.
But there isn't.
There is. There's an x squared that's common to each. So if I take out the x squared as the GCF, I'm left with what?
With the x
4 minus pi. That's right. So believe it or not, 4 minus pi is just a number. Pi, remember, is approximately 3.814. So 4 minus that is just a number times x squared. So that's its simplest version or its factored version. You could argue.
Are those pi symbols?
No, those are n's. N is a variable.